So shifting functions. And we're going to start with an example here with y equals the absolute value of x. Hopefully you all remember what the absolute value of the number is, right? The result of absolute value, guys, is always what? Well, never. Okay. Who can tell me what the result of an absolute value is all the time?
1.
No.
Oh. Oh, positive.
Positive number, right? Is there anything else that works like that? What else always gives you a positive number in math? Some other operation?
The square root.
No, not square root, the other way.
Squaring.
Squaring, right? Graphs are completely dissimilar, right? And we could put these in our calculator if we needed to, but they want us to look at these functions. Y equals the absolute value of x. Here, those are the absolute value brackets. And then they're going to have us look at the absolute value of x minus 3 inside there, and then plus 2 tacked on to the end. And then the absolute value of x plus 1, and then subtracting 4 tacked on to the end there, right? So part A, without the use of your calculator, graph y equals the absolute value of x. All right, so let's take a look at that. So any x we put in, what kind of y comes out? You just said positive, right?
The positive one.
Positive. So if I have an x of, say, let's see, negative 1, 2, 3, 4. If my x is negative 4 over here, what's my y value when I take the absolute value?
4.
Positive 4. 1, 2, 3, 4. Right? Let me get rid of that other dot. 1, 2, 3, 4. And how about x of negative 3? What comes out of the absolute value of that?
Positive 4.
Positive 3, and so on, right? You get the idea? Like that. And then we get to an x of 1. The absolute value of that is also positive 1, isn't it? Whoops. Somebody's got a lot of noise in the background. Either cut the noise or mute, please.
So it basically forms a V shape.
It does, right? And so you might have seen this graph in algebra. And it looks like this. Right? Okay. And so we'll label that absolute y equals absolute value of x. Okay. That's not too hard. So let's see what the other, boy, I missed all my points here, didn't I? Whatever. So let's see what the other things do to it. Let's take a look at the y equals x minus 3 and then plus 2. Just forget the minus 3 part. That plus 2 on the outside. Like if I was thinking of a table of values, what do you think that plus 2 would do to this graph?
It'll make it so it's more than 2.
Okay, but in general, the entire graph, what do you think adding 2 to every value in the table would do to this graph?
It'll shift it up 2.
It should shift it up too, right? Now, what about the minus 3 inside the absolute value? What do you think that'll do?
It will move it to the left 3.
Let's think about that for a minute. The minus 3. So whatever x value we have in our table, we subtract 3 from it before adding the 2. So aren't we effectively, by subtracting 3 from all the x values, kind of making the x's smaller? Does that make some sense? Well, let's take a look at it in the calculator. So if you have your online calculator, you can follow along. Let me sit down and do this. So let's go over to functions. I'm going to add a function. Now, absolute value. There's not really absolute value brackets either, but we can type this command here. F of x equals, if you want to follow me, ABS, absolute value, right? Let's just do x real quick. All right, so just type ABSX, put that in parentheses, okay? Let's just see if we got the graph right. So let's go up to graph, okay? It looks like about what we have, right? Let's fix the axes here so that we have something that looks a little more like what's in our book. I guess that's close enough. 10 or something like that. Not even that. We'll be good. Now we need to get some negatives in here. Let's get some negative x's in here, or negative y's. So I'm going to change. This is part there. Axes right there. Okay. So negative 10 to 10, and let's make a y min of negative 10 and go up to 10. Okay. Okay. All right. That's about what our graph looks like, right? So let's put that other one in there. Go back to the functions and add the other one. Now the other one was absolute value.
Absolute value x minus 3.
A, B. Now watch carefully how I type this. X minus 3, and that's going to stay in the parentheses, right? And then it was plus 2. See, outside those, so it's kind of like outside the brackets. With me? Now, we predicted it shifted it up 2, but let's see what that minus 3 does. Well, it went up 2, but what happened? What did the minus 3 do to it?
It shifted it right for you.
It shifted it to the right 3, didn't it? And if you think about that, like every x that I put into the function, it's the equivalent of 3 less than that x, right? So it makes it all happen out here to the right. You'll have to think about that for a minute to get your brain wrapped around it. But if it looks like if you're inside the parentheses, the shifting is the opposite of whatever that sign is, right? So let's go put that on our little table here. Maybe I'll use the same color red that they did. Okay. You got red? Yes, I do. Okay. So we know we went here, like here was this point like that. It was over in here from our calculator. All right. So we have that. So we'll call this y equals absolute value of x minus 3 and then plus 2. Okay? Now the other equation, starting with the x, absolute value of x, in this one we have minus 4 on the end, right? So thinking of our original blue graph, what would that minus 4 do to the blue graph that's tacked onto the end? Shift it which way?
It'll shift it down 4.
Down 4. Now let's think, based on what we just looked at, the plus 1 inside the brackets. Your immediate response is to say it'll shift it to the right 1.
But it's likely to shift it to the left 1.
Yeah, let's go to our, let's put it in our calculator and verify that. Okay, so I'm going to here. And we'll go back to functions and we'll throw that one in there. All right, let's go add function. And we said it was yes, parentheses x plus 1 and a minus 4. So x plus 1 parentheses and a minus 4 on the outside. Okay. Let's see what that does. I think we'll go down here. So I took this original red, right? And the plus 1 inside, the plus 1 moved it left 1. And these are counting by 4s, and then down 4. Okay? We're not doing consecutive intervals there. Okay? So maybe we're starting to see a pattern. Let's go ahead and plot that one. Okay? So the absolute value of x plus 1 minus 4. We take the original blue graph, right? We're going to go left 1, down 4. 1, 2, 3, 4 down here, right? And every point on this, we'll go left 1, down 4, left 1, down 4. So effectively, it'll kind of look like this, right? So let's get that in there. So this is our y equals absolute value of x plus 1 minus 4. Okay? So let's talk about what we noticed. As compared to just the regular absolute value of x, the absolute value, yeah, we'll go with that. The absolute value of x minus 3, the first one we did, plus 2 here outside the function, right, is shifted what?
It's shifted up to right 3.
Yep, so right 3 and up 2. So you notice if the plus or minus is inside the little functionality there, it's like the opposite of the sign. And then the absolute value of x plus 1, and then minus 4 on the outside, is shifted how?
It's shifted left 1, up, down 4.
Left 1, down 4. Okay, notice it's like the opposite of the sign. All right? So let's answer this question down here. How will the graph of absolute value of x be shifted to produce the graph of y equals absolute value of x minus 6, then minus 8 on the end? So what do we think? What would the minus 6 do since it's inside the absolute value?
Minus 6 will shift it 6 right.
So right
Right 6.
6, and then the minus 8 tacked at the outside.
We'll shift it down 8.
Down 8. Okay? So the only tricky part here is whatever's inside the function, right? You have to, it moves the opposite way of what the sign is, right? Like the opposite. And this is for absolute value. Let's go to this will work for any function, right? This kind of thinking. So let me we're going to the notes page now. So this will be the same for any function. Like quadratics. You know what they are, right? Their highest exponent is x squared, right? So if I had just this started with this, y equals x squared, right? And then I changed it like this, y equals x squared plus 3. What would that do to the graph of what? So why, you guys remember that?
Shift it to right 3.
You guys remember that y equals x squared is that parabola, right? So this was shifted to the right 3. Okay. What about y equals x minus 4 squared like this?
It was shifted down.
Oh, wait, no, that plus 3. You said right 3? I'm writing what you wrote.
Yeah, no, it's up 4.
Okay. I thought you said right. Yeah, up 3. Jeez.
It'll be up 3, and x negative 4 would be left 4.
Left. You sure?
I think so.
Remember, it's inside the function.
No, it'll be right 4.
This will go to it'll take that original one and move it to the right 4. Let's try another one. Y equals x in parentheses plus 5 squared minus 2. What would happen to this function? How about that plus 5 inside there? What would that do to it?
You move it to left 5.
Left
Down
5.
2.
And then down 2. Okay? So we getting the idea there? So if it's inside the function, right? Like in this case, it's a squared function. You move, it gets shifted the opposite way of what you would think. If it's outside the function, it goes up and down with plus or minus. Okay? All right. Now, so for the problem set here, the problem sets in these, we're going to skip a bunch of problems. So do make sure you make note of what I'm about to write here so you don't end up trying to do them all. Okay? So your problem set, that PS for problem set. In this case, you're going to skip the following. Okay, you're going to do all of them but the following. We're going to skip numbers 3, 4, and 6. All right, everybody got that? And I will also include that, like if you go look at it on Teams for the assignment, it'll be in the instructions portion of the assignment. It'll either be what problems you skip or what problems you do, depending on what's more convenient, okay? So does anybody have a question on shifting? There's just one little tricky part, right? If it's inside the function, it's opposite of the adding and subtracting. Does that make sense? Okay, let's do one more section then.